Hello and welcome to Math with Lou. Today we are going to be reviewing the square root. What is the square root? Let's find out. So, before we begin talking about the square root, we're going to do a quick little review here. As we should know, 4 squared is equal to 4 times 4. The square tells us we multiply the 4 into itself 2 times. 4 times 4 equals 16. We should also know that if we have a negative 4 squared, well, okay, this is also equal to negative 4 times negative 4, which also gives us a positive 16. So, because both of these numbers squared equals 16, 4 and negative 4 are both known as the square root of 16, okay? Any number that you can multiply by itself to get another number, that original number is the square root. So again, x squared, oh, maybe we shouldn't use x for an example, but if we use 5 squared equals 25, then that means that 5 is the square root of 25, and negative 5 is also the square root of 25. Okay. So, all positive real numbers have 2 square roots, one positive square root and one negative square root. Note here, this is just shorthand for positive real numbers. As we went over in my numbers video, this means the real numbers, and the plus up here just lets us know they're positive. So, anyway, as we could see from this example, 16 has a positive and a negative square root, 4 and negative 4. The positive square root is known as the principal square root, just to get a little bit of vocab in there. Sometimes we'll be working on things where the negative one we can kind of just throw away. For example, if we're dealing with, area in a three-dimensional plane, well, you can't have negative area, something that doesn't make any sense. So in situations like that, we would only work with the positive. All right. The product of two numbers, if the product of two numbers, the product of two numbers is positive if both numbers have the same sign. This was gone over earlier in one of my earlier videos. Again, when you multiply two numbers of the same sign together, it's going to come out positive. If you multiply 4 numbers of the same sign together, it's going to come out positive. As long as you have an even number of terms that have the same sign, it's going to come out positive, or at least an even number of negative terms. A square root is written with the radical symbol, and this guy right here, this is the radical symbol. This implies that we're performing the square root of something, or we're looking for the square root of something. The number or expression inside the radical symbol is called the radicand. So here I put a little example, the square root of x. In this example, x is our radicand, and this square root is our radical symbol. To indicate that we want both the positive and the negative square root of a radicand, we put the plus minus symbol in front of the root. This symbol is so useful, and this is what I love about math. Mathematicians are lazy and they come up with good shorthand ways of expressing ideas. This plus minus symbol means you have to consider the positive solution and the negative solution. So it really means you're looking at 2 different numbers. And then here I have an example. The square root of 9 equals plus minus 3. And we read that as, again, the square root of 9 equals plus or minus 3. 0 has one square root, which is 0. Very easy to remember. Square root of 0 is 0. 0 times 0 is 0. It checks out. Now, this is pretty interesting right here. Negative numbers do not have a real square root since the square is either positive or negative or 0. We know that we cannot have any numbers positive times positive or negative times negative that come out as a negative. For example, there is no scenario where x times x equals some negative number y, or negative x times negative x equals some number negative y. This never happens. This is impossible. So whenever we take the square root of a negative number, we simply say it does not exist. We can't do that. Well, so really though, I highlight the word real here for a reason. And the truth is, when we take the square root of a negative, we'd never have a real solution, a number that is an element of the set of reals. Now, when we talked about in our previous video on the numbers, we talked about a set of numbers that expands out from the reals, known as the complex numbers. In that video, I briefly go over how we can utilize the square root of a negative to get the complex number I, but that's out of the scope of this video, so I don't want to go too hard into it. I just want to point out that, again, the square root of a negative does not have a real solution. It does have a complex solution, but that will be covered in a much later video. That's typically talked about in Algebra 2. If the square root of an integer is another integer, then the square is called a perfect square. So I did a bunch of examples here. Square root of 1 is plus or minus 1. Square root of 4 plus or minus 2. Square root of 9 plus or minus 3. And I did all the way up to square root of 144 is plus or minus 12. So these numbers, this set, I listed them all out in this set over here. These are known as your perfect squares, and that is because when you take the square root of one of these numbers, we are going to get a hard integer out, and we can see for these examples, we get out 1 through 12. There is much more than these. I just listed off the first 12. If the radicand is not a perfect square, then you can either simplify the square root or approximate. So here I did the example with the square root of 8. This is the original problem we're given. If you were to simplify this, you would get 2 times the square root of 2. I'm not going into how you solve that now. That is in the scope of another video. But I just wanted you guys to know that it can be simplified to a different form. For wherever you are in your education, if you're not familiar with the simplification process, then you are better off either leaving it as the original or an approximation. You would just plug your square root of 8 into a calculator, and I stopped at the first 4 decimal places. That's usually how I like to round. Just a personal preference. You're free to go as far as you want to. And then some last notes to touch on, some things I found interesting. The square root the square root of numbers that are not a perfect square are members of the irrational numbers. So again, a lot of referencing to my video on the rational numbers. I put here the symbols for it. This is not a common symbol used for irrationals. This P here, R minus Q, which translates to the reals minus the rationals, is a more common one to use, but I like this better just because it's one symbol. But anyway, yes, whenever we take the square root of a number that is not a perfect square, we will get an irrational number out. And what this means is that the number we get from our square root is a number that cannot be expressed as a ratio of 2 integers or a fraction, more commonly known as. And the more important part is the decimal form of this irrational number will neither end or terminate, nor will it repeat. It will go on for, the decimals will go on for infinity, with no place in that infinite line in which they repeat. Pretty crazy stuff, honestly, if you think about it. But that pretty much covers this video. I talked about everything I wanted to talk about in regards to square roots. Thank you for joining me. As always, the notes will be in the description, and I hope to see you next time. Take care.